My name is Isha Kasliwal. I'm a senior UI UX designer developer focusing on design systems at Twitch in San Francisco. Previously, I was a senior UX engineer on the Lightning design system team at Salesforce. I consider myself a designer who codes. I care deeply about design, and that has what led me to focus on many of the different aspects of how design can be informed in tech, and that's why I write code. Today, I want to talk to you about how TypeScript can power design systems. I know most of the people in this group are developers, but since design systems are growing so much, ideally you've heard of the term design system before. Can you actually raise your hand if you know what a design system is? Okay. So for those of you who don't, a design system is the single source of truth which groups all the elements that allows team to design, realize, and develop a product. My old teammate and friend, Gina Ann, of Design Systems fame, has very eloquently described design systems to be composed of tangible and non-tangible elements. A design system offers a consistent and well-designed pattern library, tools for both designers and developers, code-ready components, guidelines, and plenty of usable resources. At the same time, a design system also offers some abstract elements like brand values, shared ways of working, shared beliefs about the product, UI, UX best practices, and more. It's where development work intersects with design work. A design system contains collections of rules, which include guidance as well as strictly enforced UI, UX, and code behavior in the product, constraints and principles so that your team at large is operating under the same circumstances and direction, that are implemented in design and in code. Some of the beauty of design systems lies in the fact that the design and code of the system carry all of those rules, constraints, and guidelines within them. The design and code alone, if used and maintained, can afford your company clarity, efficiency, a standard look and feel, and unity. A design system actually goes beyond just design and beyond just code. A design systems team, like my own, has to maintain an entire product of their own. So our customers end up being designers and developers that are in our own company. My team operates as a design-focused engineering team, and the engineers in the rest of our company use the components that we provide. Because we do this, we have to maintain many aspects of our product, which includes a large variety of different challenges to build and maintain. From support to documentation to messaging and everything in between, a design system is a very large body of work. A lot of companies, both big and small, like Amazon, Facebook, Google, and Shopify have design systems, and where I work, which is Twitch, which some of you may have heard of, does as well. A lot of what we maintain and what I tend to focus on is component development. Think of a component as small as a button or a component as large as a modal. We work to build and maintain all of it. The process generally starts off as ideating why a specific component, like a button, is necessary. Once we deem it important, we move on to design. And then before it goes into production, we have to write the code to build it. For many design systems teams, the main concern is the view layer and making sure there's a clear and consumable API for our company's engineers. We write and maintain our components in HTML, CSS, and JavaScript. And it turns out that in our JavaScript, we are able to maintain a lot of opinions, rules, and documentation around our designs. And at Twitch, we're able to do that by using React.js and Typescript. Here's an example of that process from our own design system. We ideated that we needed a very small UI element that could convey status in line with other elements. And based on UX research and best practices, we decided that the best UI to solve that problem would look like a pill. After ideating, we designed what the pill component would look like. This is the pill in our Figma UI kit that all of our designers use. Then we wrote the code for the pill in Typescript, which is on the left side. We created documentation, which is on the right side. And luckily, because we're using Typescript, it's really easy to generate prop-related documentation that's very detailed. And then finally, in production, on the website, the web app, the mobile app, all of our different instances of Twitch, the pill is used by designers and developers when they want to convey status in their UI. So this is one example of how it's used on our website. And this is another example of how it's being used in production. So I mentioned that we use TypeScript in our JavaScript stack because we believe that it's a powerful tool when it comes to design systems development. But what exactly is TypeScript? TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. A good summary of how it's different from vanilla JS is that it provides optional static typing, classes, and interfaces. When using TypeScript, you don't have to write all of your code entirely in TypeScript. If you wanted to, you could have vanilla JavaScript and TypeScript in the same file. Also, you can use TypeScript with React.js. A couple of benefits that TypeScript provides include style-specific typed props. Having style-specific typed props offers visual consistency, ensures prop purpose, and prevents variable mutations. If you use an IDE that is compatible with TypeScript, which most are at this point, the IDE is informed in real time by the TypeScript compiler on its rich type information. There's better autocomplete, snippet generation, renaming, and targeting across the entire code base, compilation errors, and more. And these are some examples from our code base directly. If we reference a component that hasn't been imported, the IDE will automatically add it to our import list for us. If you start typing out an enum, the IDE will automatically reference all of the possible values that you can use. TypeScript provides exportable interfaces, which makes communicating the intents and limits of your component seamless. An interface is basically the contract that the component must conform to, and it states what needs to be or could be done, but doesn't specify how it will be done. An interface contains the name of all of the properties along with all of their types. It also includes a signature for functions along with the type of arguments and the return type. For example, the title function returns a string. In TypeScript, you can also export these interfaces, allowing similar components to share the same contracts, ensuring consistency. So here we've made an interface called Core Interactive Public Props for anything that would need to share link-related interaction design concerns. For our link component, we've extended the core link interface to use the same core interactive public props. So core link will get things like the title prop for free, with added props that we want to stay specific to core link, like underline. So how does TypeScript specifically help design systems? More than anything, TypeScript helps create trust and a stronger relationship between design and development. Designers can trust that their designs are being implemented correctly, and developers can trust that they have access to all of the information they need about a component upon usage. Let me explain that further. As I was researching TypeScript, I came across a really great phrase describing what TypeScript is like: interface-oriented development. TypeScript encourages developers to develop exposing interfaces, which keeps other developers who use the components informed of what the API consists of. TypeScript allows developers to focus on exposed API rather than having to know all the code by heart. Because of this, TypeScript can enable a softer onboarding for code bases, and especially for design-related and front-end specific code, which most developers don't want to focus on, the IDE has really great autocomplete. Here's an example of how we're able to achieve developer trust by using TypeScript in our design system. Like most design systems, we provide documentation for component usage and guidelines. Something great we're allowed to do because of TypeScript is static code analysis of each component's props. So for our component pagination control, which you saw here, we have all of the possible props you could use on this component listed out in this interface. In our documentation, if you go to the Properties tab of each component, you'll find those same props listed out for our developers to easily reference. It's the same exact list of props with additional information about what the props type is and descriptions that we generate from comments in the code itself. So you can see that the interface is there. We, using static code analysis, took all of those props and turned them into documentation. We've taken it a step further by also offering developers a functional playground to test components in with the same prop list as well. On each of our documentation pages, we offer a link to open a playground for each component. This is an example of what a playground looks like. The playground offers developers a way to configure all of the props, use them, and work with them to create the version of the component that they need. The code changes in real time as well, so that they could copy and paste the code if they wanted to. By having all of our props per component listed out in interfaces, we're able to easily make use of static code analysis and provide better tooling for our developers and for our designers. TypeScript also enables designer trust. Take a component design as simple as this, a progress bar, which we use on our Twitch website all over the place. With the combination of interfaces and enums, the components can include all possible variations of design, so the developer can easily get the design right without having to rely on copying and pasting code, knowing specific class names, etc. The IDE will also include all of these values through autocomplete and smart suggestions, so the designers don't need to redline all of their design mocks or their specs, and the developers know what exact variations they could possibly choose from. Our design system also uses strict naming conventions so that our source of truth doesn't have to be production code as it is for many companies. Our source of truth can actually start and live in the design. For example, in our Figma UI kit, we have all of our typography and all of our colors, all of our text types mapped out and named based on what we would want the functional color and type variables to be. We then map those variables to props and provide the exact same type styles and color styles to our components. Because all of our style opinions get translated to props in the code, we're able to maintain a strict and defined system for all of our designs. This allows for us to rarely deviate from the system, ensuring efficiency in code and consistency in design. As a bonus, TypeScript can also enable business and user trust. According to a study done by a computer science researcher, Adrian Collier, using TypeScript results in a 15% decrease of bugs. Strong typing ensures that there will be less bugs, which helps PMs and other people focused on the business side of things trust that your features will be more efficient. And of course, the users will appreciate experiencing less bugs as well. Hopefully by this point, I've convinced you that design systems could greatly benefit from using TypeScript. But I want to close out this talk by expressing that when it comes to writing code, it's important to understand that form follows function. What does this mean? It means that the shape of our structures, and more abstractly, the tools that we choose to use and how we use them, are dictated by their functions. When it comes to web development, the purpose of everything we do is to make a more usable and safe set of websites and apps. So to take that a step further, intent follows impact. As a developer or even a designer, your intent, or lack of intent, behind anything you create follows the impact that it has on users of the web and on each other. It's always cool to use the newest libraries or frameworks, but it's important to gauge whether they actually impact the users and maintainers positively, and if the creators of the framework had safety and usability in mind. Your intent behind the software you build and put out into the world creates more impact than you might expect, so it's important to use the tools that consider everyone, safety, and trust. Thank you.